Hi there, and thank you for your question. So I'm just going to grab my pencil tool. And your question is number 69 in the textbook. Oh, I like to draw with blue. There we go. And it says that you have if you have 1.0 times 10 to the 3 kilograms, which in other words is equal to 1,000 kilograms of iron, and iron is Fe on the element table. So if we have that much of iron, how much, and we have the compound Fe2O3, and 1,000 kilograms of Fe2 we have, how many kilograms of the compound Fe2O3 altogether do we have? That's the question. So this is how you set it up. First of all, we're going to take that 1.0 times 10 to the 3 kilograms, and we have to go through dimensional analysis, where we're basically going to use conversion factors, and a bunch of them, to go from kilograms of Fe, let me just write that again, 1.0 times 10 to the 3 kilograms of Fe to kilograms of Fe2O3. That's the question. How do we get from here to here? And there's going to be lots of conversions, and I'm going to write the path for those conversions down here as we go. First conversion we have to make is convert kilograms of Fe, because that's what we have, to so we have kilograms of Fe, and we're going to do to grams of Fe, because all of our molar stuff is going to be in grams. Until the end, we're going to have to switch back to kilograms. So our first conversion is from kilograms of Fe to grams of Fe. So to do that, we're going to multiply by the conversion factor of 1,000 grams equals 1 kilogram. And because I put the kilogram on the bottom, I'm just going to move this over. I'm going to need lots of room because there's a lot of conversions in here. That's going to get rid of my kilograms by putting it on the bottom, and then I have grams on the top. My next conversion is to go from grams of iron to moles of iron. So to get to moles of iron, I'm going to go 1 mole of iron is equal to the molar mass of iron, which is, on the periodic table, 55.85 grams. That goes away, and now I have moles of Fe. From moles of Fe, I need to do the conversion factor of, I want to change it from moles of Fe to moles of Fe2O3. That's my next big conversion. So I'm going to put moles of Fe to 1 mole of Fe2O3, and because I know that I have 2 moles of iron for every 1 mole of this iron oxide, that, and now I'm converted to moles of Fe2O3. Did I say that this is a really complex problem yet? And you won't see one this hard on the test. So this is definitely a challenge problem. You won't have to do such a hard one on the test, but it is definitely a fun one to work your brain around, because so far we've done 1, 2, 3 conversions, and we're here at moles of Fe2O3. We still have to get to kilograms. So the next thing we need to do is go from moles of Fe2O3, iron oxide, to grams of iron oxide. And to do that, we need to know that our molar mass, so 1 mole of Fe2O3, so something like that, and we have to do the molar mass, so we have to do the calculation So you have to find the molar mass somewhere else. Molar mass for Fe2O3, you're going to do 2 times Fe, which is 55.85 grams, plus 3 times oxygen is 1600. Let's see. 3 times 1600. That's going to give us our molar mass of 159.70 grams. So that's going to be up here. 159.70 grams is the molar mass of Fe2O3. Oops, that's not an equal sign. I haven't quite gotten there yet. And then once I have grams, my last thing is to change it to kilograms of Fe2O3. So to go from grams to kilograms, I know that I have 1,000 grams in 1 kilogram. And that's going to give me how many kilograms of Fe2O3 altogether. So that's 1, 2, 3, 4, 5 conversion factors to go from kilograms of iron to kilograms of iron oxide. I had to go from kilograms of iron to grams of iron to moles of iron oxide to grams of iron oxide to kilograms of iron oxide. So when I put this in my calculator, I'm going to multiply across all the top. So I'm going to switch this to 1,000 just to make it easy on myself. 1,000 times 1,000 times 1 times 1 times 159.70 times 1 gives me a numerator of 1597, and then I have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros on the top. And now I'm just going to multiply across the bottom. So I have 1 times 55.85 times 2 times 1 times 1,000 equals 111,700. And now I'm going to divide. So 1597, 1, 2, 3, 4, 5 zeros, divided by 111,700 is equal to 1,429.72 kilograms of my iron oxide. And if I put that into significant digits, that's going to be 1.4 times 10 to the 10 to the 3. Oop, what am I doing? Sorry. So I have to move my decimal from here 3 spaces. So 1.4 times 10 to the 3 kilograms of Fe2O3. That is the answer. Okay, so try that with B and C. It's a tough one, but it's kind of cool to see how many steps it takes to get to that final answer.